A prompt is not an operating system. You can write a really good prompt and still get a bad result. The AI might use the wrong information. It might change more than you expected. It might even skip an important test. Or it might take an action before you have approved it. The prompt may look perfect, but the system around the prompt is weak. So in this video, I'm going to explain why one good prompt is not enough. I show you 7 controls that make AI work more safely, clearly, and consistently. By the end, you will have a simple checklist you can use before giving AI an important task. A prompt is an instruction. It tells the AI what you want it to do. An operating system controls how that work happens. It decides what information the AI should trust, what it is allowed to access, what it's allowed to change, what the result should look like, and when it must stop. How the work will also be tested, and what gets remembered afterwards. That is a much bigger system than one prompt. Think about giving work to a builder. You would not simply say, improve the house, and then hand over the keys. That instruction is too broad. Which room should they improve? What's the budget? Which walls are safe to remove? What must not be touched? Can they order the materials? Who checks the work when it's finished? And who approves the final work? The builder may be very skilled, but skill without boundaries can still create damage. The question is not only, can AI do this? The better question is, what system controls how the AI does this? In loop engineering, I think about 7 control points. Control 1, define the mission. The first control is the mission. What is the AI actually here to do? And just as importantly, what is it not here to do? For example, do not simply say, improve the checkout. We would say, review the payment screen and identify anything that may confuse the user. Do not redesign the full checkout. Do not change the payment logic. Do not implement anything yet. Now the job is much clearer. The AI knows the goal. It also knows the non-goals. This is what I call locking the mission. Without a clear mission, AI can easily expand a small task into something completely different, into a completely different task, sorry. Control 2, choose the trusted knowledge. The second control is knowledge. What information should the AI use? In the previous episode, we created project sources such as the project brief, the system map, the guardrails, the decision record, and the current state. Those files give the AI a trusted place to look. But simply having documents is not enough. You must also tell the AI which sources are approved and what it should do when the information conflicts. For example, use the approved project sources as the current source of truth. If a chat message conflicts with an approved source, report the conflict. Do not quietly choose one. That matters because the AI can produce a very confident answer from old or incorrect information. The quality of the answer depends on the quality of the knowledge underneath it. Control 3, limit the tools and authority. The third control is authority. What is the AI actually allowed to do? There is a big difference between allowing AI to read a document, suggest a change, edit a file, send an email, publish something, or change a live product. These actions do not carry the same level of risk. So the AI should only have the authority it needs for the current job. If the job is to review something, it may need permission to change. It may not need permission to change anything. If the job is to draft an email, it does not need permission to send it. If the job is to inspect a problem, it does not need permission to publish a fix. Giving context to AI is not the same as giving authority to AI. The AI may need to understand the full system. That does not mean it should be allowed to change the full system. Control 4, define the boundary and the output. The fourth control is the boundary. What is the AI allowed to touch? And what result should it return? For example, review only the payment screen. Do not touch authentication, database structure, or payment processing. Return 3 findings. For each finding, show the evidence, the risk, and the recommended next action. This does 2 things. First, it limits the change surface. Secondly, It makes the output easier to review. A vague request often creates a vague result. A controlled output gives the AI a clear shape to work inside. This also helps you compare one result with another. You are no longer asking, does this answer sound intelligent? You are now asking, did it follow the required structure? Control 5, add a stop and approval point. The fifth control is approval. AI must know when it must stop. For example, do not implement any change. If you believe another part of the system must be changed, explain why and wait for approval. That one instruction can prevent a task from expanding without your knowledge. Stopping is not a failure. Reporting a conflict is not a failure. Asking for approval is not a failure. These are signs of a controlled system. The human should still own the important decisions, the purpose, the accepted risk, the allowed scope, the final quality judgment, and any action that cannot easily be reversed. Human control should not appear only at the end. It should be designed into the process. Sorry, I got cut off. As I was saying, Control 6. Test against clear criteria. The sixth control is evaluation. How will we decide whether the result is good? We should not judge important work only by saying, that looks fine. The test should exist before the work is approved. For a software change that may include, does the original path now work? Do the nearby paths still work? Does the system still reject actions it should reject? Did the AI stay inside the approved scope? For a written document, the test may be, are the claims supported? Were assumptions labeled clearly? Did it follow the required structure? Did it leave out private information? The criteria depends on the job, but the principle is the same. Compare the results with clear standards, not with your mood. Control 7. Update the learning. The final control is learning. What should happen after the work has been reviewed? A normal AI conversation often ends with a useful answer. And then the learning disappears inside the chat. Loop engineering closes the loop. After the result has been checked, we ask, what did we learn? Did a rule change? Was a new risk discovered? Should a decision record be updated? Should or what should the current state be updated to or updated? Should this become a new guardrail? But remember the rule from the previous episode. The AI can draft the update, the human approves it. We do not allow every idea, mistake, or temporary assumption to become permanent project memory. Only verified learning moves back into the system. That means the next AI task begins with better information than the last one. A simple example. Imagine you ask AI, improve my checkout flow. That sounds reasonable. But what does improve mean? Can it change the design? The payment logic? The database? The error messages? Can it implement changes? How will the work be tested? The prompt does not answer those questions. Now place the same task inside a controlled system. The mission is identify confusion on the payment screen. The trusted knowledge is the approved project brief, system map, and guardrails. The authority is review only, do not implement. The boundary is payment screen only, do not change payment processing or authentication. The output is 3 findings, each with evidence, risk, and recommendation. The approval point is stop before implementation. The evaluation is check the recommendation against requirements, mobile path, and error path. The learning step is record only the approved decision and test result. The AI has not necessarily become more intelligent. The system has become more controlled. That is the difference. Now, what I want you to do before your next important AI task, write down these 7 things. 1, what is the exact job? 2, which information should the AI trust? 3, which tools or actions is it allowed to use? 4, what is it allowed to change and what must stay protected? 5, what exact output should it return? 6, where must it stop for human approval and how will the result be tested? 7, what verified lesson should be added back into the project afterwards? You can put these into project instructions. your current task prompt, or your review checklist. Depending on whether the rule is permanent or specific to that task. The important thing is that the 7 controls exist. Because one long prompt is not the goal. A controlled working system is the goal. Final principle. A prompt asks for the work. An operating system controls the work. It controls the mission, the knowledge, the authority, the boundary, the approval, the test, and the learning. This is how AI becomes more structured. This is how you reduce drift. And this is how you gain more leverage without giving up control. Build with leverage, but keep control.